Hi guys, in today's tutorial we'll be looking at Field Theory 2 past question. I'll be solving question 3b, which says a transmission line with characteristic impedance of 300 ohms is terminated in a purely resistive load. By measurement, it is found that the minimum value of the voltage on the line is 5 microvolts and the maximum is 7.5 microvolts. Determine the value of the load resistance. Before we dive into solving this question, please do well to like and subscribe and also hit the notification bell on my YouTube channel. Thank you very much. We have the characteristic impedance of 300 ohms. Now, as you can see, I wrote here that you should note. Now, when we talk about AC circuit, we talk about impedance, whereas in DC circuit, we talk about resistance. And when we talk about impedance, we bring in two factors, the resistance and the inductance. So the inductance is an imaginary component, whereas the resistance is the real component. Then this is your minimum voltage, and the minimum voltage is 5 microvolts. Then the maximum voltage is 7.5 microvolts. And the load impedance or the load resistance is what we're looking at. It's supposed to be the load impedance, but due to the fact that what they gave here was a purely resistive load. So purely resistive, it means that this component here, your inductive component, is tends to 0. That means it's 0. So what you just have is the resistance. So you can see that impedance is equal to resistance. So that's why they ask you to find load resistance. Now the formula we're going to be using is what I call we are going to be using this transmission coefficient formula. Now the transmission coefficient is equal to the reflective coefficient plus 1. Now the transmission coefficient, this subscript V here indicates that it is for voltage. Now the transmission coefficient of a voltage is equal to 2 times the load impedance divided by the characteristic impedance plus the load impedance. And also there's a formula called the voltage standing wave ratio, which is VXWR. And the VXWR is equal to the maximum voltage divided by the minimum voltage. And there's a relationship between the transmittance coefficient for voltage and the voltage standing wave ratio, which is what you see here. Sorry, the reflection coefficient is equal to the voltage standing wave ratio minus 1 all over the voltage standing wave ratio plus 1. Now let's go into the solving. Now first of all, we are going to get the voltage standing wave ratio. Since from the formula, you can see from the formulas given, the only one that has a complete parameters is just the voltage standing wave ratio. So we start with that one. So the voltage standing wave ratio is V max over V min, which is what you have added here. If you point your calculator, you get 1 over 1.5, which is a unitless quantity. Also, the reflective coefficient of the voltage is, like we said, voltage standing wave ratio minus 1 all over voltage standing wave ratio plus 1. So you get it, and when you get it 0.2, to get the transmission coefficient is 1 plus the reflective coefficient, which is 1.2. Now you put that value into this other formula that we know that the transmission coefficient is equals to 2ZL all over ZO plus ZL. So you make your ZL subject of formula. I think that's what I did here. If you can see, that's what I did here. And after that, you solve and you can get that the load impedance is 450. You can also put it like this. You can say it is equal to 450 ohms plus J0. Like I said initially, it is a purely resistive load. So if it is a purely resistive load, that means everything concerning inductance is off. So in a transmission line, there's no inductance, so it's just purely resistive. Thank you very much. Please do well to like and subscribe, and also hit the notification bell so in case any video comes, you'll be the first to be notified. Thank you and God bless you.